Okay, so real quick in this video, I'm going to talk very briefly about the special right triangles that we're going to see over and over again in this class and even later on. So the first one that I want to talk about isn't necessarily a special right triangle, but I like to think of it as such because it's the simplest possible Pythagorean triple, and to me, that's pretty special. But anyway, so obviously 3, 4, 5, and any dilation therein, and its angles will always be 37, 53, 90. Okay, now anytime we name or talk about special right triangles, we're looking at the short leg ratio to the long leg to the hypotenuse. Okay, so in this case, the short leg is 3, right? The long leg is 4, and the hypotenuse is 5. Okay, so here we see it 3, 4, 5. Long leg, short leg, hypotenuse. And then here we see it again, right? So this one's been scaled up, right, by a scalar of, or dilated by a scalar of 2, right? But we still have 3, 4, 5. Okay. And again, we see the exact same angles, about 37, about 53. And that's another thing. We'll learn precisely what these angles actually are when we get into what's called arc trigonometry. So that's a few weeks out. We're almost there. Okay. The other one is a 1 to 1 to square root of 2, right? So that means we're 1 to 1. Okay, so if we didn't know this hypotenuse, we could real fast just do the Pythagorean theorem. We could say 1 squared, so leg squared plus the other leg squared, equals our unknown hypotenuse squared. Well, 1 squared and 1 squared, they're both 1. 1 plus 1 is 2. And we take the square root. Our hypotenuse, of course, is the square root of 2. Hence, 1 to 1 the square root of 2. So why is this one special? Because it's isosceles, and we will always get angles of 45, 45, and 90. Okay? So we don't really have a long or short leg here. They're both the same length, but we're still doing leg to hypotenuse. Okay, and here we see another version of it, right? So 4 to 4, this would simply be 4 times the square root of 2, because going from here to here, I dilated by a scalar of 4. Okay? And now we have the last one that we're going to look at, 1 square root of 3 to 2, right? So here we have the parent one, we'll call it, right? So 1, okay, so we don't know the length of the long leg. We can guess what it is because of what we have here, right? The ratio of short leg to hypotenuse is 1 to 2, right? But we're going to pretend like we're not that smart. So we're going to solve it with the Pythagorean theorem. So 1 squared plus missing leg squared equals our hypotenuse squared, or 1 plus x squared equals 4. Subtract 1 from both sides. Take the square root, and we can't simplify that any further. And there you have it, 1 to square root of 3 to 2. Okay, short leg to long leg to hypotenuse. Right? And here we see a dilated version of it. Oh, before I get ahead of myself, the angles on a 1 to square root of 3 to 2 are always 30, 60, 90. So 30, 60, 90. Okay, and the 30-degree angle is always in between, we'll say, the long leg and the hypotenuse, and the 60 is always in between the short leg and the hypotenuse. Okay, anyway, so over here we see we must have been dilated by a scalar of 7. 7 times 1 is 7. 7 times 2 is 14. So that means our missing long leg here would simply be 7 times the square root of 3. Okay, so let's look at a few, more broad examples. So right here, if we're trying to find missing legs, so fill in these question marks, right? Um, Well, let's do the Pythagorean theorem. So right here, leg squared plus leg squared, so that'd be 4 plus 36 equals 40, right? And that's equal to our hypotenuse squared that we're looking for right here. Okay, and we see that h is simply going to be equal to the square root of 40. And we can't leave it that way. That's too big of a number to leave unsimplified. So we're going to say the hypotenuse is actually equal to the square root of 4 times the square root of 10, or 2 square root of 10. Okay, so that would be our precise answer. And 2 square root of 10, of course, my handy dandy calculator, 2 square root of 10 is about 6.32. So our hypotenuse is about 6.32 in length. Okay, so here we see another one, and dead giveaway, 30, 60, 90, right? So that means this must be a 1 square root of 3 to 2 because it's 30, 60, 90. So that means that this long leg must be 5 times the square root of 3. That's because the long leg is always equal to the short leg times the square root of 3. So short leg times the square root of 3, and that's what we get there. And then the hypotenuse is always twice the length of the short leg. So this must be 10, right? And that's all we need to do there. Okay, here we see another example that I forgot to put the angles on. We'll go ahead and say that this is about 53 degrees. Okay, if this is about 53 degrees, that means this guy's about 37 degrees. So this must be a 3, 4, 5 based on the angles. Okay, so that means we dilated by 5. 3 times 5, right, gives me the 15. So 3 times 4, right? I'm an idiot. 5 times 4 will give me 20, and my missing hypotenuse must be 25. Okay, and then over here, we see that we've got an isosceles. And of course, this is a right triangle. So if it's isosceles, there's only one possibility. These angles must be 45 degrees. Okay, and 9, 9. So this is obviously a 1-to-1 to square root of 2, right? So that means the hypotenuse on a 1-to-1 to square root of 2 is always the length of the legs times the square root of 2. So that means this guy was dilated by 9, so it's simply 9 times the square root of 2. Okay, so that does it for this video on special right triangles. Like always, let me know if you need anything. Send me an email or come see me in class. Otherwise, that's it for this. Goodbye.